Hello, everyone. Um, Today I'm going to show you kind of the ins and outs of the Research XR toolkit. So what you're going to first want to do to get the project started, going to go to the code base here, which I will have linked in the description of the video. We will go down to code. We will go down to download the zip, extract it as well. Then we'll go over to Unity Hub. Right here, you want to click add up here in the top right, click add project from disk, and then you're going to point to it wherever you have it stored. Once that's done, it will probably ask you to install the editor version. I'm using version 6000 right now, so Unity 6.5. That's the main version I'm using now. Click on it, load it, or after it's downloaded, do all that, and you should be left with this. So if you don't see this, what you're going to have to do is go down to scenes down here and just click on working. If you click on that, it's going to load all this up, be good to go. This is kind of just like a basic template, just really to show you kind of the ropes of everything. So Research XR Toolkit builds on top of SXR Toolkit. So you'll see that up here. And most of the functions that work in XR work in um, RX RXT. So sorry, it's a little bit of a tongue twister. If you want to access the functions for RXT, or you kind of want to see the back end of it, you're going to click this prefab right here, which is our player right there. Click it, click the drop down arrow, click on RXT background or backend, and you're going to see a couple scripts here. So you're going to see data collection here, sound manager here, foveation control, and unique ID manager as well. Foveation controller, I think, only works right now with the HTC Vive Focus Vision. I do not think it works with the HTC Pro Eye. So if you're using the Pro Eye, you're going to want to disable that. The main meats of this has been just the complete overhaul and rewrite of the data collection. And so this is a big script that you do not need to memorize everything for. So I wouldn't look too deeply into it. If you want to add like another column, you're just going to do this. You're going to type in thing here. That's what I want to add, and then we're going to just do map that to thing map it there, and that's all you're going to have to do to add that, to add like a new data column. Add that, just point it towards the point that you want, and it will update that automatically. So that's how you add a data column. Let me quickly go over, don't save that. Let me quickly go over kind of the fields in here. And so um, once you add a new data column, what you're going to want to do is click this three dot button up here and hit populate all data points. Click on that. It will do all that. It will add it to this down here. But first, let's go over these ones. Is focus vision. If you toggle this, it will get the data for the focus vision headset. If you untoggle it, it will have it for the HTC Pro Eye. So when it's untoggled, it is going to save the data to this path, to the data path, which is right here. We'll go over that a little bit later. And then you have a backup download path as well, which would save it here. That's just in case if it can't find this path, um, it will go to the backup one. This one right here is for the focus vision. As you can see, focus download path, /SD card 2. Backup path is SD card right there. And so by default, this will save the data to the micro SD on the HTC Focus Vision. But if the SD card for some reason isn't inserted, or the micro SD card isn't inserted for some reason, it will try to download it at this backup path, which would be actually on the internal thing on the headset, the internal storage. So that's that. Run on start, I would recommend just leaving this enabled. It just starts the data collection as soon as the program is running and working. There is a backup way to call it, which is I think RXT start data collection. We can look at that a little bit later. Generate trial summary. This one generates a summary of the data fields in a trial. And so instead of having a very large data file, um, it takes the averages of everything and calculates that, and then it spits it out into the trial summary file, and we'll go over that a little bit later. The event summary file, very similar to the trial summary file, but this one's looking at events. And so typically you want to look at small parts, especially for eye tracking and stuff like that. You kind of want to look at like, when the stimulus is applied and stuff like that. That's kind of where you want to look. And so this allows you to generate an event summary file that looks at a specific point in time in a trial and generates a file based on that. Another one here is recapture baseline on trial change. And so once the trial changes, it will update this and it will recalibrate the baseline so that your offset is good. Going on down to these things here, you will have a drop down arrow, click that. This is basic data, and you'll see channels. So this one, uh, you know, you can edit the header of it. You can do the toggle, like whether you want it on or off. You can switch them around, right? If I want trial as my first column, then I can do that. Um, and so the same goes for like camera tracker as well. If you don't want camera tracker at all, you can just click this and it won't print the camera tracker. It won't track the camera tracker at all. Um, if you ever like mess up or anything, just go back up here, hit populate it all, and it will reset everything back to kind of how it was. And so that's good. But you would mainly want to use this if you didn't have like a facial tracker. You can disable that. And eye expressions as well. If you don't have that, you can just disable that quickly right there. So, and then lastly, we have simulate eye tracking. This just generates fake eye tracking data to make sure like that your baselines are getting where they want to be, where you want them to be. That things are where they want them to be. I know sometimes it's a little hard to have an eye tracking headset hooked up to a computer and you're running tests and everything like that. So this kind of just simulates it so you don't have to put on the headset and whatnot. So um, very good there. Sound Manager kind of does what it says. It manages the sounds. So if you have a sound like a UI button, you would name your audio name there. You would add your MP3 file. You would drag your MP3 file or FLAC file or whatever. You would drag that into here. Um, and then you would be able to call it. And so we'll look at that. We'll look at that. But you can add as many as you want. You know, name this, thing sound or whatever. Actually, you don't want spaces in this. So you can do that. You can add audio clips, whatever you want. I don't know. Maybe I want air pump for some reason. Yeah, I don't know. But you can add clips and then you can call them. I recommend this. It's just a little bit simpler of a way to manage your audio instead of having 50 audio sources. You have one audio source, and this one all set up and good to go. It also is unique in the fact that you can tell it to move the audio source to a different area, so you have like that 3D sound effect. And so we'll take a look at that. Foveation control. This does foveated rendering, and so you can edit these values in here. I think when I was doing it, I didn't notice much of a difference at all. That's kind of why I left it at 45, but maybe you guys will find a difference. Maybe you guys won't. So try and plug different numbers into these and see, what result you like the best. And then lastly, we have Unique ID Manager. This is actually used by the data collection to generate a unique subject ID. So like if you have a participant 1, you have a participant 2, you have a participant 3, instead of going through the trouble of like manually entering that, it auto generates that and it's actually this run counter thing right here, which I'm going to delete really quick just so we can get a kind of a good idea about what it's about. So with that said, that's kind of RXT. If you want to look at all of them, you can go down into your project. We can go to RXT here, and there's a bunch of other ones as well. You can look at this is the main one. So Research XR Toolkit. This allows you to call the functions throughout. And so you can see like unique ID right there, the start recording if you don't want to run the data collection at the start baseline with a default time of 1 there. The audio manager stuff, you just call it there. And a bunch of other random functions in here. Most of them, um, or not most of them, all of them I will have a description for in the GitHub description, so you can look at it there. So moving on over, kind of give you a quick rundown of this stuff here. iCalibration Launcher, you will want to enable this just by clicking that checkbox there. Um, so enabling it uh, will launch the eye calibration for the HTC Vive, or sorry, HTC Pro Eye. You do not need it enabled for the HTC Focus Vision. So we'll disable that for now. Here's kind of like a test script that kind of shows you some of the basic functions, how to call things, how to change things as well. And so you can see like we have a couple of conditions here, like a control, a condition A, condition B, delay between trials, event summary duration. Uh, as I was talking about, like if you want to capture a specific moment for a certain amount of time, you would call that function. We'll take a look at that. And then baseline duration. This determines how long you want the baseline correction for the eye tracking. And so baseline correction is primarily used to kind of set an offset for a person's eye to see, how far off of baseline do they get aroused and stuff like that. And so you can adjust baseline duration. Typically, we actually keep it at 1 second is what we've had in our previous projects, and that's what I recommend. So looking at this driver class, or sorry, this driver script here, we have a couple things here. We have our array of conditions, a demo kit, participant setup. Once again, it auto generates a unique ID. It's basically just a counter. That's all it's going to do. It's going to count up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and count that up, and that is what is assigned to the unique ID. And we'll take a little bit of a look at that after you kind of run the program and you kind of get an idea of it. So uh, this is how you call those functions in the Research XR toolkit. You're just going to want to do RXT dot and then the function name. So you can do RXT dot play audio, and it'll do that. You will actually, I don't know if you need to import it. Oh yeah, up at the top you need to include using RXT. Um, include that, and that allows you to do, this. It allows you to do RXT that get unique ID. And so if we copy this, we go over here, we search for it. Yeah, she's right here. So that's how you call functions in here. If you want to add functions down the line, add them in there, and it will automatically add them. So you can kind of take a look at this and go through it. Just really basic stuff there. Probably the main one you're kind of going to want to look at is this run trial one, which takes in a trial number and then takes in a string of conditions. And so it kind of says trial starting this. This is kind of like a really basic trial research study kind of setup, like really, really basic. You're just looping through trials and whatnot. And so let's take a look at this. So RXT start baseline duration. We set that up here. So we set it at 1 second there. We wait for 1 second. We do the next thing, which is starting event summary timer. And so this will collect the next 2 seconds as we've denoted there. So this will collect the next 2 seconds of data, summarize that, or say you take an average of that and then spit it back out into a file. This one right here, playing trial audio, play audio once, and then we select game points. So if we go back into RXT prefab, we click the drop down arrow, we go to RXT backend, we go to sound manager. We have our game point audio right here, audio name. And so you will want to like just basically copy this and paste it in here. And that's how you're going to want to do that. You next need to, for the 3D audio effects, since you're working with VR, you're going to want to use 3D audio. You're going to do a transform dot position, and that's going to tell it where it should place the audio source. So you can attach it to an object or whatnot, or like another game object you imported in. You can set the volume of it and the pitch of it. By default, these are set to 1, so you technically don't even need to include these at all, but I felt it was a little helpful there. Um, this one triggers haptics, so like haptics in the controller. So if you kind of want to, once they click a button, you want the controller to vibrate a little bit to give some feedback. You're just going to want to call rxt.trigger haptic, and that will trigger a haptic response in the controllers. Set state kind of is the English term that we've used for defining like what period of a trial we're in. So instead of looking at, oh, we're in trial 1, step 0, right? It's a little hard to decipher. So sometimes we just need a plain English one. And so using the set state allows you to set basically when, or like in basic English, what's going on at this point in time. And so we'll take a look at that as well. And then your uh, SXR, once again, this is built on top of the super simple extended reality toolkit. And so you can call functions like XXR in it that will trigger the next trial to go on. And so enough talking. All right, so now we're going to run it. We're going to click the play button up here. Wait for it to do its thing. And we'll see a bunch of debug logs in here. You'll see a bunch of errors because I do not actually have the headset plugged in at the moment. It's at the lab. And so you're going to see a bunch of errors pop up. You can toggle these on and off just by clicking them and the errors. And really all you're going to want to focus on is this one here. And so hopefully by playing the demo, you kind of get a little bit of an idea about how the program is running, what is happening where, and how you would take this and modify it into um, your own program and your own application. And so we'll let this run for a little bit more, and we'll stop it there. So as you can see, it failed to find controller because I didn't have it plugged in or whatnot. But you can kind of see like starting trial 5 condition is B, starting baseline, starting event summary timer, playing trial audio, triggering haptic feedback, all of those things. And so to actually see the data, it's going to be in this folder right here, this data folder. And you're going to say, well, this folder is empty. What's going on? If you click it and you hit Control R to refresh, they're going to pop up. So do that. They will update and pop in. So don't be too alarmed if it's not there. Let me talk about the unique ID generator. So that's actually in here, the run counter. And this just kind of denotes like what person ran the what subject ID, I would say. So it basically just counts how many times the program has been run. It works when you build the file. It works when you build the file and when you run it on the actual application and stuff like that. It'll work then. And so it's just an easy way to keep track of, participants instead of, long, lengthy numbers. You can just simply use 1, 2, 3, 4, 5, up and up and up. And so as you can see, it's just a basic TXT file. It has the value of 1 because this is the first time we've ran the program. We can go to data, and you'll see it creates a folder called one. And so in that folder, there are three different files. The data file that has the date and the time that the program is run in military time or in Europe time, I guess, as well. We'll click into that one. You're gonna see it's a bunch of different fields, a bunch of different stuff. This will also be in the GitHub description about like kind of what we're looking at here. But mainly if you hover over it, I think a lot of this is kind of self-explanatory, I guess, in a little bit of a way. You'll see like exposition. So these are the um, camera positions in there as well. We'll move on over a little bit. This one's the Z rotation. So that's what rod is for. It's the rotation. Move over a little bit more. We'll see here. This is the combined pupil. So if you remember, we toggled on that setting for simulating eye tracking. This is all it does. It simulates the left and right pupil. Um, and so these are fake values, but you can kind of get the idea of what it's doing. We scroll down. Remember, we set the baseline to 1 second, so it captures the baseline for 1 second. So if we go here, we scroll on over, you can see we were at local time, or probably best to actually use trial time past here. Um, we were at 6 seconds when we started it, and then we specified that we wanted it to capture a baseline for 1 second. So if we go down, we go down to like 7 around here. We'll look down a little bit further. And then there's our baseline after it's been corrected. So it takes the values and it just kind of says how far off of the offset it is. So bunch of other data fields, a bunch of other stuff, but that is like the big data file. You're then going to want to go to event summary one. And so this one, remember, this one captures a very small part of the program that you specify. So if you say like, I want this to capture this for 2 seconds, that's what this does. And it captures just this tiny little moment um, that you can look at, and maybe when something flashes on the screen, you want to capture that. That's what you would use this for. Um, and it just calculates the average. So we can kind of see here, let's see trial. So you can see it does trials, that it's incrementing the trials here, and that we're looking at a very, very small point in time. So that is that. That's the event summary one. Once again, it's kind of like used to look at just a very small part of it, to see, when the stimulus enters the screen, what's happening. This one here is trial summary. And so this one just takes a summary of the trials. So we can kind of see here that it takes a summary of that phase. This one right here, trial 0, it's a little bit long because it's taking the averages of everything in the trial. And so this is trial 1, 2, 3, 4. And all this is doing is just taking the average. Obviously cannot take averages of string variables. So it just, if it's a string value, it spits out, or it writes to the TX or the CSV file the latest data point in that variable. So you can kind of see here, like we're just printing out the averages of the Z-rot rotation for the headset. We'll look over here. This is the average combined pupil size for the entirety of trial 4. And then yeah, 3, 2, 1, 0. That's what we're looking at here. It takes the average values in a trial, computes it, spits it out into a simple CSV file, so that you don't have to scroll through all of this and calculate it and do a bunch of stuff in Excel. So you don't have to do that. It will do that for you, as well as also giving you the massive data file. So that's kind of just a quick overview of RXT, what it's about, and I hope that it's of use to you. Probably the last thing I will mention is this player spawn point game object. And so you can actually move this around. It's empty or it's an invisible object, so you can't see it. And what this is used for is to reposition the player to where you want them to be. And so typically we had a problem with the HEC Pro Eye in which like a participant would sit a little bit off centered and it would kind of like ruin the illusion or ruin, what was going on. Um, and so what this does is this repositions the player to be wherever you place this object. And so I'm going to place it down there. I'll place it far off to the right just so you kind of get an idea about what's going on. And I'll just hit play up here. And you'll notice it will like take a second and then it will finally move them over. And that's just to make sure they're kind of like settled in, they're in their position, and then it will move them over. So we'll wait for this to start really quick. No. And then you kind of saw like it shifted over um, the camera to the right position that we wanted it in. And so that was quite simple. That's attached down here to this XR origin. So go to RXT prefab, open up this XR interaction setup, scroll down, and it's right here, VR player reposition. Um, Everything's set up. So, but if you want to change anything, you would just go here and do that. So, thank you for listening, and I hope that this program is helpful. Bye.